Hello, welcome to the session. In this session, we will see how to use an interrupt along with the timer, and we are going to do the same BCD counter, but here instead of calling the function, we are using the interrupts. Let's go to the code. Okay, coming to the code. So actually, we define the header file first, then we have to define the interrupt. So here we are using timer 0, so we are defining the interrupt 1. That's for the timer 0 t naught. Okay. The sequence has to be maintained. For external interrupt, it is interrupt 0 has to be written here. For timer 0, it is interrupt 1. For external interrupt 1, it is interrupt 2. For timer 1, it is interrupt 3. Like that, the sequence what we have in the IE register, same sequence we have to follow here. Then I'm defining one local variable x for the for loop to execute for certain amount of period because timer delay is very less. Then we are giving a mod value here. In the interrupt, I'm giving a mod value. So now if the P1 value is less than 10, then it will increment, else it will become 0, 0. That means it is mod 10 counter. Now coming to the main program, first we define the port which we want to use where the LEDs has to be connected. Then a T mod, timer 0 in mode 2. Already we discussed this in the previous session. Then TH0 118. However, you can give any value here depending on your calculation. Then TL is loaded with 00. So because TH value will be automatically reloaded to TL, I will show you that also. Then interrupt enable register. So we give 82. That is one is global interrupt is the last MSB bit, and second interrupt that is timer 0. Then start the timer with the TR. If you observe in the previous session, I used declaration separate S bit declaration. Here it's another way of writing the directly timer 0. Then this is an infinite loop. Okay. Now once we start the timer, it will wait here till the interrupt comes. When the interrupt comes, it will go to interrupt service routine. This is the ISR. It will execute this ISR. Again, it will come back to this infinite loop and it will wait here for the next interrupt. So every time it gets an interrupt, it will go here. It will execute this loop. Okay. Now let's build the project. Let's enter to debug mode. Okay. So now here you can see I have and here you can see these things by using the peripheral interrupt, IO, and timer. All these options are available. So open these windows so that we'll be able to see what are the changes happening. Now this is port 1, this is for the timer, and this is for the interrupts. Now if I run the code step by step, see first P1 I made it 0. Then T mod, now it is some other mode. Now I set it to 8-bit auto reload mode, and then I set the TH value to 76H. Remember, this is a decimal value, it will be converted to hex equivalent and it is shown here. Right now TL is 00, so there is no change in the TL. Now I will enable the IE register. You see that this is enabled here and timer 0 is enabled. Okay, so this is interrupt 0, interrupt 1, interrupt 2, interrupt 3, and interrupt 4. Like that, we have to give the sequence in the programming. So this is it start sequence start from the 0. So we have given timer 1. Now if I further run the code, it will start the timer and it will wait here for the interrupt to be generated. Now you can see here for the TL is incrementing for every click. So it will take a lot of time to overflow. So I will just run the code directly. So now if I run the code, you can see the counting happening in the port 1. Every time it overflows, it will go to a function and it will run the code. Okay. Now here also you can see timer overflow flag is also set whenever the overflow happens. Now let me stop this and come out of debug mode and we'll go to a Proteus. So the same setup I am using, only I'm changing the code. So I'm just browse the code to new hex code and then click OK, because my file is project is new, the project new, so a X file is generated. In that new X file is generated that I have loaded to Proteus. Now if I run the code, it should work with a mod 10 because we are given a mod 10 value. So 2, 3, 4, 5. You can observe the changes in the LED. Again, lower nibble has to be connected to the LED. It will go up, count up to 10. Now it is 10. Now it will go to reset. It will reset back to 0 0. So that depends on what mod value we give. Okay. Thank you. Have a good day.